All right, so today we're going to go over how to use my C++ project template because I know a lot of you guys have been asking for it. So we're going to get right to it. Just to start listing off what you need to know, it's really just basic C++ and maybe a little bit behind the scenes of how make works would be useful but not required. You don't need to know how CMake works, and honestly, you can just follow most of this guide without actually having to understand make or CMake. So let's start with looking at the CMake file, which is literally just, if you look at it, it adds these subdirectories for parser and adder. And you can go ahead and install CMake tools if you don't have it. And VS Code will tell you that way you can get the coloring like this. Okay. So what does it mean by add subdirectory? All that it means is just it goes into these subdirectories, finds their CMake, and adds them to the files to build. Right. So let's look at one of the CMakes here. I pulled up the CMake for adder. This is the CMake for adder. It's considerably different. This is where the meat of the building takes place, right? Just as an overview, you can think of CMake as basically building a make file for you, right? So you'll see I have a make file right here. Okay, we'll just pretend I'll just delete it, right? If you look at it, it's pretty complex. I did not write this at all myself, right? So we can go ahead and delete this actually because we don't need it because CMake will actually build it for us, right? So don't worry about any of this to make files. So you look at this CMake, the only things that are important right here are really just the name of your library. All right, so a library is you can think of as just like a set of binaries that tie to a certain implementation. Okay, so I can theoretically, right, give you a library, right, which is like an object or a binary file, and you don't have to like find out, like, you don't need the code for it, right? You don't actually need the text. And this, it's good for security reasons. For example, in 241, what they use it for, like testing, right? They don't want to give you the answers, but they want to allow you to check against the answers, right? So to provide the binaries here, which is similar to this library, right? And so all we're doing is really, at the end of the day, for the CMake file here, is just creating this library from all the CPP and H files that we have. That's it, right? And then eventually, every single time we want to run something, right, we basically link them against this library, right? That way, it knows the function definitions and declarations and implementations, right? That's what it's for. Um, so let's just walk through this real quick, right? You have sources and includes. We take them from, this is basically how you access a variable in CMake. We take these, put them into a library, right? And then, you can basically see that we are adding another library from the parsing branch because, all your code might use like a different library, right? In this case, they all use parsing. And there's only one different like part to this project, which is adder. Um, and so we need the parsing dependencies, right? So we just add that as well. And then when we want to make an executable, right? So we make the executable from a CPP file, and then we link against the library that we've made. Okay, that's what's going on. Same thing for the test. It's the exact same thing. Just make sure, you also add your test sources here, right? That's what we have. And this is how we actually use Catch 2. So you don't actually need to like download it from the internet and blah 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 and work around it. CMake does that for you. Actually, if you're really curious, that they're inside this dependency file, which I actually get ignored. So you won't see it, but when it builds the project, it will automatically build those dependencies with that. Okay. So that's roughly how the CMake file works, right? If you want to use it, all you do is change this library to whatever like sub project you're in, right? So in this project, we basically have this adder like sub part to it that all it does is like adds two nodes. It's completely like arbitrary. For example, in one of your project, it may be BFS or DFS, right? As a sub project. So you can change this to, let's say, BFS lib if you're going to do BFS or whatever, right? It's just a name that we give it so that we can reference back to it, much like a variable, right? So you could name this whatever you want, but of course having better naming schemes is going to be good for you. All right, so all you do is you change this library name. That's about it. Everywhere that you need to use it. And then maybe you want to change the name of the main executable and the name of the test executable, but as long as they don't conflict, it's fine. You don't really care about it. So the three things you need to change are, I repeat again, the library name, right? Adder lib, okay? The executables, right? Main, right here, and then maybe this one, right? If you have some other dependency, let's say instead of parsing, VFS depends on a separate subpart of the project that only deals with like nodes, right? So like node lib or something, right? Then you would change parsing lib for node lib, and then you would also change how you access that directory via here. Okay, that's about it. Super easy, just like that. You also might want to add the includes here, but technically you should only need to do one of them, I believe, but just I have both of them here because that's how I got it to work. So yeah, just make sure if you want to add a separate like library, this is how you do it. Okay. So this is how you add a subproject. So what happens if that library has no dependencies? Well, if you look here, it's basically the exact same thing, but simpler, right? We don't have the include library, right? Should be decently self-explanatory there. Okay. And then I provided you guys a couple shell files, which are basically just a list of like command line commands that you guys can run. So if you look at bake, which stands for build plus make, right? That's sort of my moniker there, bake. You can use these commands to help, to you can copy paste them into terminal, or you can just run this. But I'll do them one by one to sort of explain what is going on. And so let's see where we're at right now. Right now, you don't see from my command line, but we're actually inside the CPP project template at the overall directory. Let's say we want to build the entire project, okay? All I do is we type cmake, right, 3 and then period, okay? And then it'll help, write our build files, right? And as you can see, right, I did not have a make file there before. It just recreated all of it. And yeah, so, your make files don't really matter. And it actually just rewrites a make file, right? So if it doesn't exist, it makes it and then rewrites it. If it does exist, it just rewrites it. Okay, so you literally don't have to worry about the make file. Like I could just delete this and it'll be fine, right? All right, and then after you've built it, right, you want to actually make the executables, right? So we're gonna run make just like from your class, right? And as you can see, right, it's built all these targets, right? So it started off by building this dependency called parsing lib. It built these targets from that cmake file, if you remember, right? And then it built adderlib, and then it built those. And how does it know how to build those? Well, we told it to basically look in there in our cmake, right? So that's what it does. There's a dependency there, okay? By the way, this project thing, you don't have to worry about it. This is just a name for it. Yeah, cool. So if you want to run like, let's say your tests, right? So I made a test script here that basically goes into each directory and runs that, that test. So all you need to do is just like, you can run test, /test.sh, right? And you can like copy paste this and add in another test file if you wanted to. There's actually a better way of doing this, but I was just lazy and copy pasting was fine for the time. So yeah. The last thing about this project template I want you guys to look at is source, right? So source actually, I've actually put in the example from our project, what it looks like. None of this code will work because you don't have the dependencies for these. So it's just really there to show you. I mean, there's nothing really important here to show. But how I built this project template is basically the idea is each sub project, right? Each algorithm is a separate entity, right? You can treat, here we have PageRank, right? You can treat PageRank as its own entity with its own CMake files, with its own include, its own source, its own main, and its own test, right? So this overall project directory is really more of a amalgamation of all these specific projects, okay? And so really, what we want to do is theoretically, we just need to add subdirectory to all these projects once we've included them, and they should work seamlessly, right? As long as all the dependencies are there, right? And that's what this is for. So, in your project, instead of an adder, right, you might have another one called VFS, right? It'll just be like an extra one, right? I put all the data stuff here, right? Parsing is another like sub project to this overall project. And so what source is here for is to actually run the entire project and show that it works, right? I've actually included these utils and util.h from, this is actually taken from one of the 225 projects, okay, the MPs. And what it does is it's explained in the README. You can sort of read it. but it allows me to pass in a command when I run the script to specify a certain data directory, or any other like command line arguments I wanted to add to my project, right? So not really too important. You don't really need any of the util stuff, right, for the command line. Let me pull it back up. Right, you can see this is how I add it, right? So there's a nodes file and edges file that I add arguments for if you wanted a help and an H, right, to add help to, for someone who is new to the project, doesn't know how to use it, right, they can run that, right? So that's the idea there. Okay, that's about it. If you look at the rest of the file, it's literally just, oh, parsing. This is showing that parsing actually works, right? And we put some stuff out to the console to show our grader. BFS, yeah, it worked, right? You can see what ID we're going to where, how many connected nodes, how far it is, etc. Right? A star, page rank, all the good stuff here, right? And we've commented and stuff like that to show our grader. So yeah, you can take a quick look at the shell file, right? This main doesn't do anything right now, but it theoretically runs the actual main. It can't run it because, of course, we don't have the dependencies there. And then, yeah, that's about it. For the git ignore, right here, you want to just make sure you ignore anything that is not needed. So anything that is built. So for example, I could actually ignore this build, but I guess I just forgot to. I've basically included everything that you should ignore. As you can see, they're grayed out here. Everything that I've ignored is grayed out. And when it ignores something, it basically will not be added unless you forcefully do it, which don't worry about that. But you will just be unable to commit it to the repository because, I mean, you don't need it, right? When you build the make file, it does it for you. You don't need it. So yeah. Yeah. So yeah, that's about it. If you have any questions, you can always reach me on Discord or CampusWire. All right. Hopefully this was helpful.